Good morning, good afternoon, and good evening. Today we have factoring day 3, factoring by grouping. Step 1, you're going to group the 4 terms into 2 sets of parentheses. It's really important that you don't combine like terms. You might be tempted to do that right off the bat, but we don't want to do that when we're factoring by grouping. Step 2, we want to find the GCF of each grouping of parentheses. And these can be different in this case. It's okay to have 2 different GCFs. And we'll show you what that means as we go through. Step 3, we want to write the common matching binomial as one factor. It's very important that these match. Again, we'll show you in 1 second. And step 4, circle the remaining parts and write that as your last binomial factor. So, let's hop into question 1. For question number 1, we have 2x squared minus 5x plus 10x minus 25. And I know you might be tempted to combine here in the middle, but we don't want to do that. Step 1 tells us to group the 4 terms into 2 sets of parentheses. So, my first set of parentheses is just going to come over those first 2 terms. My second set will be over the second 2 terms. Now all we're doing is finding the GCF. That's step 2. It's okay for these GCFs to be different. So for my first set of parentheses, I look at the 2 and the 5, and I see that there's really nothing in common there that I could pull out. But for my variables, I have an x squared and an x, meaning that I could pull out the common x between those 2 terms. So x is my GCF in the first set of parentheses. In my second set of parentheses, I have a 10 and a negative 25. Here I should be able to see that I can pull out a 5 from both terms. However, when I get to my variables, there's no variable in my second term, so my GCF is just going to be 5. Now I can rewrite this expression with the GCFs successfully pulled out front. So I'm going to start off with my x, and then what's left over from the first set of parentheses is 2x minus 5. And in my second set of parentheses, I pulled out my 5, and I have a 2x minus 5 again. For step 3, we want to write the common or the matching binomial as one factor. So we should be able to see the common binomial here is we have a 2x minus 5 here and a 2x minus 5 here. So all I'm going to do is write that out front, 2x minus 5. That's my common binomial. My last step is to circle the remaining parts and write those as the other binomial factor. So the remaining parts I'm left with, after I pull that 2x minus 5 out, I'm left with an x out front there and a plus 5 out front in front of my other binomial. So when I write this as my second binomial factor, I'm writing x plus 5. So now we've successfully factored our original expression. And if we wanted to check our work, all we'd have to do is set up the box method. So if I wanted to check this, I'd put my 2x minus 5 here, and then my x plus 5 here, and just go through my box method. I'd get a 2x squared, I'd get my 10x, my negative 5x, and my negative 25. You can already see that the terms are matching. Down here I've got my 2x squared, negative 5x, negative 5x, positive 10x, and my negative 25, negative 25. So we see we're still an equivalent expression. We just factored it to get our new answer. So the factored answer here, just to clarify, is my 2x minus 5 times x plus 5. Try the question on the right side of your page on your own. For question number 2, we're going to start it just like we did the first problem. We're going to group our 4 terms into 2 different sets of parentheses. Next, we're looking at what's my GCF here. So for my first one, my 6x squared and my negative 4x, you can see that 2 goes into both of these terms. So I'm going to divide by 2. And I also have an x in common. So my GCF is 2x. When I pull that out front, I have a 2x, and I'm left with 3x minus 2. Now for my second term, as I'm sure you're probably seeing already, negative 3x and positive 2, they really don't have a noticeable GCF that we can pull out. So we have to have a little foresight here, but we know that we want to have a matching binomial. So we know we want to get 3x minus 2 on this second half of the problem. We're very close to that already, but the difference is the sign. So here I have a negative 3x compared to my positive 3x here, and here I have a positive 2 compared to my negative 2 here. If I wanted to switch the signs on this binomial, what I would have to take out would be my negative 1. If I divide by a negative 1, that's going to change the sign on every term. So negative 1 is going to be my GCF for the second part of the question. So now I put that GCF out front of my negative 1, and I do my division. I'm left with 3x minus 2. For step 3, we wanted to have that matching binomial, and we do. We have a 3x minus 2 on both sides of this expression, so we can rewrite that in front of the problem. So we've got our 3x minus 2. And then what I have left over here is a 2x out front and a minus 1. So that's going to be my second binomial, 2x minus 1. I've successfully factored the expression. And again, if you wanted to check your work, you could just set up the box method. Try the question on the right side of your page on your own. Alrighty, on to question number 3. We're going to set it up just like the last couple questions, sectioning off 2 sets of parentheses here, grouping my 4 terms up into 2 sets of parentheses. So, to start, I have my 7x squared minus 14x. I should be able to notice that I can pull out a 7 from both of these, and I can also pull out an x. So my GCF is going to be a 7x that I write out front. What's left over inside is going to be an x minus 2. First part is factored. Up next, I have negative 6x plus 12. Again, you've got to be able to look ahead in the problem and notice I want to get a positive x minus 2 as my second binomial. So in order to be left with a positive x here, I need to pull out that negative 6 out front if I want to just be left with that positive x. Okay, I have to change the sign, so I've got to pull out that negative. So luckily that negative 6 can be pulled out of both terms. It can be pulled out of the negative 6x, and it can also be pulled out of the 12 because negative 6 goes into 12. What I'm left with is exactly what I wanted, that x minus 2. Now I have my matching binomials. So for step 3, we want to write that common matching binomial as one factor. We're going to pull out that x minus 2 and write it right out front. So I have my x minus 2. X minus 2. And what I have left over is my 7x minus 6, and that's just going to come as my other binomial factor. So 7x minus 6. Be sure to try question 3 on your own. Question 4. The area of a picture frame is represented by 3x cubed plus 15x minus 21x. Find the length and the width of this picture frame. What is the shape of the picture frame? Explain your reasoning. So a couple parts to this question, but when I'm thinking about the shape of a picture frame, most picture frames I know are either squares or rectangles. In either case, my area formula is going to equal length times width. Since I already know that they gave me the area, which is 3x cubed plus 15x squared minus 21x, I should be able to break this up into its 2 separate factors. So all we're doing is we're trying to factor this term that they gave us into its length and into its width. In order to do that, I'm looking, and the first thing that I see is I notice that I can pull a GCF out of all 3 of these terms. So my GCF that I'm going to pull out from all of these terms, my 3, my 15, and my negative 21 all have in common is that a 3 goes into every single one of them. In addition, when I look at my variables, I can pull out an x from all of these terms. So my GCF is going to be 3x. When I rewrite this now, I'm dividing out my 3x. It doesn't go away. I got to put it out front, so I have a 3x. I'm left with an x squared plus 5x minus 7. I've now successfully split my area into the 2 terms right here. So 3x is really going to represent my length, and then my x squared plus 5x minus 7 is really going to represent my width. So to answer the last part of this question, what shape is the picture frame? If I have a length of 3x and a width of x squared plus 5x minus 7, these are two different values. So if I had to guess, my length and width are different sizes. Therefore, it can't be a square, so the resulting shape must be a rectangle. And just like that, we've solved our problem. We've got our length, our width, and the shape of our picture frame. And that is some beautiful math. Have yourself a great night.